Hello. In this video, we're going to start talking about frequency distributions. So far, we talked about why we do surveys. It all starts with a research question. That research question guides the actual research method we use to answer that question. And if we chose surveys as our research method, then we went ahead and constructed survey questionnaires. We selected a sample. Hopefully it was a probabilistic sample that would give us a representative sample of the population. We sent our survey to that sample. Respondents filled the questionnaires. They sent them back to us. And we constructed a data set with those responses, right? That's where we are. Now, the fun begins because we're going to start analyzing those responses, analyzing the data set. And of course, the analysis we use depends on the type of question we had in the survey, and of course, the type of variable that that survey question became. So we're going to start with analyzing questions that were close-ended, right? Questions that were close-ended, remember, they had different categories of responses. The responses were limited to certain categories. And when we made data sets, those became variables that had only a certain number of answers possible, right? We even use data validation tools to make sure that we entered all of these categories consistently in the data set. So now we're going to talk about how to analyze that type of variable. So variables can be of different measurement levels, right? In general, they can be either categorical measurement or interval measurement, right? Categorical measurement, as the name implies, are when the values for these variables fall into distinct categories, right? Now, variables that are categorical in measurement, they can be either nominal or ordinal, depending on those categories. Nominal measurement is a type of categorical measurement. And under this type of measurement, the variables have these categories that cannot be ordered in any meaningful way. An example of a variable of this sort would be, for example, religion, right? They're nominal because the categories in this variable would be, let's say, non or Jewish or Christian or Muslim, and there is no order to them. It is just names of religions. So they cannot be ordered and therefore are just nominal measurement. However, categorical variables can also be of ordinal measurement. And under this level of measurement, variables have values that have an obvious order, right? For example, values that, or variables that are measured with Likert scales, of course, they can be ordered by level of agreement, right? Strongly agree is a little more than agree, and agree is a little more than neutral, and neutral is more than disagree, and disagree is more than strongly disagree, right? If we order them in terms of agreement. Others, most attitudes variables, or even age in categories, or income in categories, those can be ordered, right? Now, interval level measurement refers to variables where they are measured in scales of equal units. For example, age in years, or income in dollars, for example, or height in inches. you know, when you look at two values that are measured in, in inches, you can know exactly the difference between these, two values. Or when age is measured in actually years, you know exactly the difference between a 20-year-old and a 50-year-old, right? The difference is 30 years old. You can know the intervals in between values exactly. But in categorical measurement, you don't know what the difference between one or the other is really exactly, right? You can know there is no real exact way to measure what the difference is between a strongly agree and agree. We know one is more than the other, but we don't know exactly by how much, right? And finally, a dichotomous or dummy variable is like it could be a mixture of the two values of measurement. These are special types of variables that can only take two values, right? Male, female, yes or no. These can be either ordinal or nominal, depending on what they are, and they are of categorical measurement. So categorical variables from survey questionnaires, of course, they come from closed-ended items, right? Closed-ended items have categories for their answers. So these types of questions yield categorical variables in a data set. For example, here you have the variable race, right? That is a nominal, right? These are the values. There's no order to them. Years of education in years, that's interval level, right? We can know exactly the difference between two values. Number of children is also, of course, an interval level variable. Age in years is also an interval level variable. Political party, that can be nominal or ordinal, right? If you can order them in terms of how Democrat a respondent is. So strong Democrat is more Democrat than independent. A strong Democrat is more of a Democrat than not a strong Democrat, and so forth. And like we talked about, religion is, of course, another type of categorical variable that is nominal in this case. So for all types of categorical variables, in order to describe their distributions, right, we need to use frequency distributions. A frequency distribution table shows how many respondents chose each category, right? You have all the available categories, and you can put in a table or a chart how many respondents chose each category. That is a frequency distribution. There's two types of frequency distributions. One is the absolute frequency distribution, and that's the one that shows you the raw number of respondents in each category. And the other one is the relative frequency distribution that shows you the percentage of respondents in each category. For example, here, the General Social Survey asks a sample of Americans whether they think sexual relationship between two adults of the same sex is either always wrong, almost always wrong, wrong only sometimes, or wrong all the time. And here we have a frequency distribution of the responses for that variable, right? 500 respondents said it was always wrong, 55 almost always wrong, and 846 said not wrong at all, right? This is an absolute frequency distribution because it's showing the raw numbers of respondents that chose each category. The relative frequency distribution shows the percentage of respondents that chose each category, right? So it expresses the number of respondents in each category as a percent of the total number of respondents, right? For example, here, not wrong at all is 56.6% of all respondents chose this category. How did I get this? I divided the number of respondents in that category by the total number of respondents for that question. Now, relative frequencies are useful, or more useful, I should say, than absolute frequencies, because we can use them for comparisons across categories and we can compare frequencies across different variables as well. Now, to compare two or more distributions, we have to use relative frequencies rather than absolute frequencies, right? Because percentages standardize distributions, right? They put them all on the same basis, right? Percent, of course, means per 100. So comparisons on percentages compare two groups as if both had 100 observations. So this allows you to examine two or more groups with very different frequencies and still make fair comparisons. For example, here, for that same question, right? We know that in 2016, they asked this question and 1,806 responded the survey for that question. And this is the distribution, the absolute frequency distribution. For 2018, as we saw, 1,495 respondents answered that question. And you see the totals are different. So it's very hard to see if there was a change, right, in the number of people who said not wrong at all. Here, there were more in 2016 than in 2018, but then again, there were more respondents altogether. So it's hard to compare absolute frequencies. If instead we use relative frequencies, we can quickly see that the percentage of respondents saying not wrong at all has actually grown, right? We are, now that we have put it in percent terms, is as if each year had 100 respondents, right? And this is what we would have looked like if there were only 100, right? So this is, now you can compare and see that tolerance for homosexual relationships has increased in those 2 years, right? The percentage of people who say always wrong has decreased, and the percentage of people who said not wrong at all has actually increased. So relative frequencies are very useful for making comparisons. We can use tables. Of course, tables give us the most amount of information, but we can also use charts, right? Tables are good because we can present absolute and relative frequencies side by side, and it allows you to present several variables in one place. Charts, on the other side, on the other hand, they can help convey the information very, very quickly and effectively, but they take more space as well. So here is an example of this. This is, of course, the table with the relative frequency distribution for the variable of tolerance of homosexual relationships in 2018, right? This is a bar chart. You can make horizontal bars, or we can make vertical bars, or we can make pie charts, right? They help us present the information very quickly. And this one pretty much jumps at you that the biggest percentage is, of course, not wrong at all, represented by the biggest, slice in the pie, or the tallest or longest bar. So there are pros and cons for constructing tables and charts, and there is also specific guidelines that we should follow when we're constructing tables and charts. And we will turn to that into the next videos. And we will end this week's lecture by showing you how to construct frequency distributions using Google Sheets. So stick around for our next video. Thank you for watching.